All right, so I want to start with a simple example just to show you a few more of the settings. So under create again, tyFlow, let's open the editor, and I would like you to follow with me if you're new to tyFlow and just right click and say preset flows and simple physics flow. So this just creates a very simple flow that just creates some cubes that fall down and they are physics objects. So this is an actual physics simulation. Now, before we get into how this works, I want you to click on tyFlow and let's just go over some of these main settings for tyFlow itself. So first, of course, you have the editor. This is how you open the editor. You can also click on this arrow and say center editor window. So sometimes if you have maybe 3 monitors like me, you minimize the window, put it somewhere, then you have like a web browser on top of it and you can't find it. So if you ever can't find it, you can just click on this and it'll bring it to front. So it's actually useful. Then under main settings, you have the tyFlow window enabled by default, or the simulation rather. You can make that disabled. So I showed you that earlier. This is how you disable the simulation. Or you can only make the simulation enabled during rendering. So this is also very helpful, especially if you have a heavy scene. So I'm gonna leave it at enabled. Now, one thing that maybe you don't know about is that you can show the name of tyFlow instead of the icon, right? So maybe this is my destruction cubes, and here it is. So now if I make another tyFlow, I can rename it, and that way I don't have to keep guessing, right, which tyFlow is which if I just have all of the icons looking the same. So this is helpful as well. Now, multi-threading is enabled by default if you have a multi-core processor. Now, time step, very important. Throughout the course, we're gonna keep increasing the time step, especially for cloth simulations. So right now, it's only basically calculating how these cubes should interact once per frame. But sometimes when you have the cubes moving very fast or you have a lot of them, you need more accuracy. And the way to increase accuracy in the simulation is to set the time step to maybe half a frame. So you see that the simulation actually changed. And it changed because it's more accurate, because it is now being calculated twice in every frame what should be happening. Now, if I set this to 1/4 frame, you see it changes again. So basically right now, we should be looking at a much more physically accurate simulation than we did when it was just being simulated once per frame. Now it's being simulated 4 times every frame, and we're getting something much more accurate. And when you're working, especially on cloth simulations, this can make a huge difference. Now, also, you might not know about this timescale option. So there is another way to do slow motion using the retimer, which we're going to do later in the course. But if you just want to sort of subtly slow something down a little bit, you can maybe set the timescale to something like 0.8. And this will simply slow down the whole simulation internally, to 1/8 of the speed, like this. So I'm going to leave it at 1. Next up, we have the cache. So really nothing to mess with here. It just saves your simulation into cache, right? So now I can just play it through in real time without it being calculated every time. So it is helpful if you have a fast SSD drive in your computer. This is helpful for all sorts of simulations. Phoenix FD water simulations especially benefit greatly from a fast SSD to save your cache onto. Next up, we have the GPU. So I do recommend that you have at least the 1070 GTX NVIDIA card that supports CUDA. I'm right now running the 2080. Now, a lot of these particle bind settings we're gonna revisit when we work on the cloth simulations, because a lot of times you need to add more steps to the simulation. Similarly to adding more time step here, you can add even more accuracy by raising the steps for the solvers. So this applies to the standard particle bind solver, the CUDA solver, we can raise the steps here as well, and then the physics solver also. So one of the common questions that I see on YouTube is, why are my objects wiggling on the floor, right? I want them to just stop when they fall down. So if you increase the simulation substeps here from maybe 6 to 12, it's gonna take longer to simulate, but it should eliminate that sort of bounciness on the ground, and they should just calm down and stop. So I'm gonna set it back to 6. Now some important settings that I do want you to know about, because you're gonna use them a lot, is this default gravity. So when you add a physics shape like we have here, you can see that the cubes are falling down. And that is because they are being influenced by this default gravity of -1. If I turn off the gravity, they're just gonna stay in place in 0g, right? And it's just gonna float like they're in space. Now I can also set this to 1 instead of -1, and now they're gonna be going up instead of down. So that's how you can easily reverse gravity and do all sorts of cool stuff. So I'm gonna set it back to -1. And then you have this ground collider. So as you can see, automatically the cubes are bouncing off the floor, and the floor is enabled by this ground collider. So I can turn that off, and it's just gonna keep falling basically through the floor until infinity. So I'm gonna turn it back on, and by default, the tyFlow ground is exactly where your scene grid is, right? So it looks correct like this. Now I can also increase the height of the floor, and you can see what that does. Pretty self-explanatory. Now these settings we're gonna go over more in the future as well. Restitution is basically bounce, or how much the objects bounce off of the floor. So if I set this to 1, they'll be just bouncing up and down like this. And then you have static friction and dynamic friction, which basically means how much energy they lose when they either hit the floor or they hit each other. So again, we're gonna play with that more in the destruction / fracture lessons. Now this CUDA setting here, that's for special cases, and you don't really need to turn that on. I know it may seem sort of confusing and you might want to turn this on, but don't do it. If you have a CUDA enabled graphics card, it's gonna work just fine and you don't need this. So next up we have the retimer, which we're gonna go over later. We have the interfaces. This is helpful for interaction with Phoenix FD. And then we just have some help files about and updates. So you can check for updates for your tyFlow version here. That's helpful for sure. So just wanted to give you an overview of the main tyFlow settings here. And in the next lesson, we're gonna go into how this is put together, why it works, and how to recreate it from scratch.